Hello everyone. Let me introduce myself. My name is Ronen Shapira, and I am the Director for 5G Cybersecurity Solutions at Fortinet. And this is a discussion panel with three organizations, and we're going to talk about cybersecurity consideration in private 5G environment, and specifically private 5G and 4G, and specifically around industrial verticals and manufacturing. We're going to try and do it short and sweet. And I'm very happy to be joined by my colleagues. So I let them introduce themselves. Hakeem, maybe we start with you.
Hi, everyone. Thank you for organizing this panel. I'm Hakeem. I work for Airbus in the digital transformation teams and IM teams as a telecom expert. And I'm in charge of the design of our worldwide private 5G solution. I'm also co-chairing the GSMA Digital Industry Working Group. In this one, what we try to do with my peers and colleagues from industries and telcos, focus on the simplification and adoption of private 5G for enterprise. Also identifying new opportunities for innovation, collaboration, and actually aim in developing new solutions across the industrial value chain. That's for me.
Liron?
Yeah, thank you, Ronen. Hi, everyone. My name is Liron Ben-Chorin. I'm leading system engineering for OneLayer. At OneLayer, what we're doing is providing a solution that's very much tailored for the private LTE and 5G market. It's a software solution that comes in providing tons of capabilities that are cybersecurity related to make sure that the standard of security of private cellular will be similar to what we are used to from IT and OT environments.
Thanks, Liron. So I think this is a great triangle because we have both the industry perception and maybe also a large enterprise perception from Hakeem. We have a cybersecurity vendor from Liron, and another cybersecurity vendor that focuses throughout the vertical landscape, so both enterprises, industrial enterprises, and 5G providers and 5G networks. That's Fortinet. So let's start first of all with trying to set up the playing ground. Is that we see that real adoption of private wireless network, whether it be 5G or 4G, is mostly happening in industrial vectors, and mostly within these industrial verticals. Manufacturing is very prominent. So Hakeem, maybe I'll start with you. Why is that? What are the main drivers that drive this adoption, specifically in this market?
Thanks for the question. I would say many. And also, I will point you to a discussion that we had lately in a published white paper that we did at GSMA around private 5G industrial networks that you can download, that was actually posted last week. There we have presented the many use cases that today attract the industries, and I would talk very shortly on this, and it's around mainly industrial automation. So AGVs, for example, for Airbus is one that could handle very heavy parts, replacing cranes and things like that, but also logistics AGVs. So somehow this is also combined today with augmentation of workers, with connected devices, smartphones, smart glasses, that are used in many ways for work order, team management work orders, HR things, but also real-time voice assistance. And also sometimes it's synchronized also with the shop floor tools that are used by the workers themselves. All of this is like a small kind of intelligent bubble, automated bubble, and synchronized bubble, in which 5G makes that glue together. Okay. Mm-hmm. Of course, there's many more. There's XR, process augmentation, remote assistance, And one that is, I think, good to mention here is, industrial IoT with edge OT monitoring, machine data acquisition, AI on top of this. So as I said, 5G is bringing that glue together between data extracted from the machine and also the upper layers, AI and automation, of course.
Great. Thanks, Hakeem. Liron, anything to add from your side?
Sure, I think I'll add shortly. I'll just say that all the use cases that Hakeem is touching here, I think what they can really benefit from is reliability and coverage. And I think that the glue that Hakeem is referring to, this is the key differentiator. I mean, a lot of time 5G is associated with higher bandwidth, with lower latency, but the fact that in an industrial environment, we can have this protocol that will ensure uptime that's close to 100%, that makes the ability to support these kind of use cases in a reliability that we were unfamiliar with before the addition of 5G and LTE to the organization. To me, that's the key driver for these type of use cases, for many use cases to come. And in addition to that, I mentioned briefly coverage. It's also the ability to not only have the connectivity being reliable, but rather to have it across your entire facility, right? There are no dead zones. There are no areas where you are lacking connectivity, where suddenly the AGV that Hakeem mentioned, for example, will just go down because it's lacking coverage. The indoors is different than what we're used to. So these are the main parameters that I think are critical for 5G environments.
So what I hear, and I completely agree, there's a quite well-defined use cases or very clear use cases that would justify the adoption of private 5G. Plus, we have the criticality, the critical nature, the reliability, the coverage of 5G that makes it just a great technology in these environments. I want to add something else, which I think is even more maybe primordial, is that there is a lot of work that was done prior to 5G even being enabled. And that is the entire work that was done around Industry 4.0, which define not only certain use cases, the need to mobility, different requirements, but also the strategic and business levels of this. And it is the manufacturing, the industrial, and specifically the manufacturing sector actually came already with this framework ready and is more mature to actually take advantage and use 5G because a lot of the work that was done and is still being done around Industry 4.0. So that's great. Now, so we have these we have this market vertical, and they're adopting private 5G and 4G environments, right? And they're doing it to enable use cases, right? We heard from Hakeem several use cases. So when you introduce private wireless network, are there any, you introduce it to an existing, normally it's an existing environment, right? It's not a whole new environment that you are building. You already have your production lines, you have your requirements, you have your different reporting requirement, you have different regulations that you have to meet. So when introducing private cellular network in that environment, what might be the new or additional cybersecurity aspect that must be taken into consideration and dealt with in these environments? Liron, maybe you want to start in this one.
Sure, I'll be happy to. So in essence, one of the major differences between a standard IT network to a cellular network is that a network that's cellular-based is more flat, right? Like everything has to go through the core. You have one mechanism that's in charge of all the switching, of all the routing, and that leads to different types of requirement when it comes to setting rules in place that will prevent lateral movements, that will make sure that east-west traffic, right, traffic that maintains within the cellular network, will not be used in a malicious way, that traffic leaving the network will be monitored. So the fact that we're having a network that's different in terms of its architecture for switching leads to the needs to have different types of solution to prevent lateral movement. Another thing that I think is worth mentioning here is that by design, cellular networks introduce organization to potential cellular attacks, right? I mean, some threats that are cellular related, like signaling storms and things that can be used only in a cellular environment, previously not affecting organizations, now are introduced also to the enterprise in their factory environment, right? So that's another thing we need to account for. And lastly, I think one thing that maybe is, I hear it a lot coming from utilities, but it also applies very much to manufacturing. There's a lot of geo-related capabilities that are introduced to us with cellular too. In the end of the day, we cover such large areas, and what we can do with cellular is to have a lot of mobile devices, right? It's devices always perform handovers, move from one location to another. So having the ability to make policies and restrictions that are based on geography, you know, to make sure that a certain device, for example, only operates when it's in the shop floor, and if it's moving to a different location, it will no longer receive the same type of connectivity, is another thing that we can now do with private cellular that's becoming very interesting.
Great. Hakeem, anything from your side?
Yeah, definitely. I mean, for me, telecom networks in general, not specific for private 5G, but also for MNO and carriers, you know, have a large attack surface. And to me, end-to-end security is crucial there. So for me, what needs to be done, you know, from the enterprise standpoint, is identify the key threats on this specific technology, but you know, it also applies to Wi-Fi or LAN. It's no difference there. We have what API exposure threats. You know, more and more automation is offered by SBA or service-based architecture. More open stuff means more attack surface. Denial of service that Leon touched on, identity spoofing, malware, viruses, but also supplier threats, you know, suppliers that embed your SIM cards, even if they are, you know, great companies, I would say, it still represents a threat. You can clone SIM cards. Then you have threats on infrastructure, threats coming also from the transported applications, so OT type of application, for example. Also, with the new solution, you have cloud or hybrid solutions, you know, basically multi-tenant clouds on the internet, which provide even an increased risk for you know, let's say hybrid or cloud to edge orchestration. We also have RAN sharing, slicing, so many. IT and OT convergence is also representing new cyber attacks and so forth. So that's for the examples. We'll talk about what we can do about it after this.
Yeah. So I completely agree with everything that was said. I want to add maybe a you know, higher perspective in the sense that in maybe not all, but definitely the absolute majority of use cases where we are trying to where 5G or 4G is required to enable, right? It's only a component within a much bigger ecosystem, right? So you have the devices on one side, you have the network on the other side, but then you have the applications, the tool, whether there be OT tools, industrial IoT tools, AI, automation, and everything, and they would be located in different edge compute or sites. It can be locally, it can be somewhere in the cloud, it can be regionally, and of course, these environments will include different vendors with different applications, different players, so it's a multi-tenant environment and so on and so forth, right? So looking at the entire picture, and because the important thing is the use case, right? This is what I want to achieve, right? I don't want to just play with 5G. I want to achieve something. For that, I need the entire end-to-end ecosystem. So the question is, I put in 5G, right? There are specific security considerations that have to take place because of 5G technology itself, and we'll touch upon that in a second. But then I also look at, okay, that's part of the puzzle. So if I want to achieve a use case, how do I secure that use case? So it starts with the devices, the network, the 5G network, the control plane, the user plane, the compute site, the application, the users who access it. How do I segment? How do I avoid lateral movement and so on and so forth? How do I secure any connectivity to an external unsecured network and so on and so forth, right? So looking at the bigger picture, I think, is very important. How does my regularity compliancy is affected when I do that? Is it being affected? and so on and so forth, right? So I think it's definitely, I think that the conclusion that we're coming to is definitely there are security implications that has to be taken into account, and really they are covering everything. So if we go, so I said I added to your argument saying, okay, we also have to look at the big picture, right? So let's go back to 5G and LTE technology as a private cellular technology in this case, which is really a connectivity technology, right? It's a mobile connectivity technology with a lot of benefits and capabilities compared to Wi-Fi, for example, but also a lot of complexity that is introduced to achieve that. So just looking at the technology itself as a connectivity infrastructure and a connectivity technology, what are some of the cybersecurity impacts or consideration, and what measures should be taken to actually mitigate them or deal with them that go beyond what we would consider to be native 5G security? Hakeem, maybe you want to start.
Yeah, definitely goes back also to the previous points, but for the enterprise perspective, firstly, cellular technology is new. The understanding of it, how it's built, and the built-in security feature is also new. So, I work with the cybersecurity expert in my company, and even today we still argue on what component is the authenticator, right? Is it the HSS AUSF? The SIM card, is it the AAA server, or is it the combination of all of this? And how do we distinguish the secure and secure the access, for machine to machine or human to machine? So that's what you need to consider. We'll not go through all of this today, but we need to go back to the basics. You have models. Maybe the zero trust model is fundamental here, and the key points that it kind of presents there is user application authentication. So identity trust or untrust, by the way, device authentication, endpoint protection with validated operating systems and things like that, and trust in general. We then can extend all this thoughts to visibility or observability of what is happening in the network, who is connecting to it, what machine, what human is connecting from which location to do what exactly, and monitoring, security monitoring. And if there is any unsecure operation, then you have to stop it or to remediate the threat. So again, in our case, there is also data protection, sensitive data, proprietary data protection through data classification, which can be also tackled in segregation per domain with different level of security applied to each domain. Yeah, so that's basically what I can give you as simple examples.
Yeah.
But the more it's evolving, the more you see new threats that could appear. Coming back to the API stuff, today we're launching with the GSMA Industry Forum an alliance with the Camara Alliance, which is the API Gateway Alliance.
Yeah, the Open Gateway.
It's something that everybody wants to try, but it's also something that you need to consider as being very risky.
Yes,
it's going to provide you more exposure to attacks. So, yeah, that's what I can say.
Yeah, Liron, from your side, again, looking at the network as connectivity technology.
Yeah, I think Hakeem made some really great points. I really like the way I look at it. We need to treat these networks the same way we treat our IT and OT environments, right? We have the same type of devices that we now connect using cellular to confidential zones in our organizations, following models like zero trust and making sure that we follow the same type of methodologies is critical for this new environment too. And my takeaway, and I feel like I'm just going to add on top of what Hakeem said a few more points for thinking. about, but it's mainly, I think that profiling devices and understanding how the use cases operate in the network is critical. You want to maximize on your ability to have visibility to the devices, to understand which device is currently in use in the network, how is it operating. This will also make it much easier to detect any anomalies, be it with the data, with the signaling, the behavior of the device. And this is a key, it's instrumental in being able to detecting attacks in the network. And in addition to that, I always tend to say visibility is critical because it provides you with the ability to manage your assets, but it's also sort of a means to an end. Another thing that you need to do is to use the information or the insights that you receive from the profiling the devices and the behavior in the network in order to be able to set restrictions in the network, to make policies that are based on context, to receive alerts, to do enforcement, right? So whenever anything violates an existing let's say, rule that you have in place in your network, you want to be familiar with it. So I guess these two elements are critical, right? Like be familiar with your different assets in your network and use this knowledge later to make context-based policies in your network that take all of this into account. That's my view.
Yeah, I think these are, both of you raised very valid aspects and impacts, cybersecurity impacts when we're looking at the network just as a connectivity. We're not looking at the bigger picture, right? I want to try to simplify that. To say, if we look at the 5G technology, a private 5G or LTE, you have control plane. For me, what do you need to look at? And I assume that the core itself, so the SBA core or the EPC, whether you use 4G or 5G, is secure. For me, it's a black box. That is, I trust that whoever is the 5G provider who delivers that, that black box is secure. But what do I have? I have the controls plane, talking to my UEs, my devices, my antennas, my G node Bs, my E node Bs, and then I have the user plane. This is where the data goes through, right? And then I have exposure, different type of exposure. Some of them are API exposures, for example. Some of them are just connectivity to external networks, and so on and so forth, right? So these three areas have to be, and this is just providing pure connectivity, have to be, there are attack vectors that they enlarge the attack surface, and they have to be secured. I think that having that, and I mentioned, assuming that this SBA core or the EPC, whatever core we're using, is a black box, the context becomes extremely important. So being able to retrieve context from that black box will allow us to be much more granular in intelligence in actually applying security everywhere else, in the exposure point, in the data plane, everything, everywhere else. So this is very, very important. So security for the data plane, security for the control plane, security for exposure. Plus, we have to remember that the network is being put into an existing OT environment. And OT has its own security models and its own compliance requirements and so on and so forth. And by introducing 5G, without doing anything, we actually take the risk of actually breaking that security infrastructure, security compliance that is there. So we have to take care of that. So for me, that's trying to simplify everything that was said so far. So hopefully so far our audience, got an idea and understanding, although relatively high level, on the complexity of cybersecurity consideration in private LTE and 5G networks. I think it's very important. I think it's very critical, specifically when these environments are critical environments, right? They are serving critical use cases. Cybersecurity is crucial, and we all know of NIS2 coming into effect next year, and so on. And there are other regulations which are coming to effect, who are actually going to put a lot of emphasis on cybersecurity and resilience. So that fits well into that. Now, we want to make it sweet and short. So to close the discussion, what I want is really a few sentence summarizing of the main point. What are, Liron, maybe we'll start with you. What are the key, if you have to suffer and say, okay, just 3 key cybersecurity consideration, in private 5G and LTE environments in these industrial and manufacturing verticals, what would they be, these four main consideration points that you need always to keep in mind when thinking or implementing private 5G?
It's a great question, and before I'll even get to it, I'll just start by saying that I think it's what we see here, going to the beginning of our conversation, is that it's a matter of time before these networks will be in wide use, right? Like we see that the amount of manufacturing organizations, enterprises that have already adopted these networks are twice as much as they used to be in 2021. And as this will evolve and we'll see more and more of these networks, so will the attackers become more sophisticated, as they always do, right? And we'll have more and more threats that we'll need to account for. I think because of that, what we generally need to do is to keep the best practice methodologies, make sure that we have security in mind from the design stage to the implementation stage. And the way to do so is to basically follow those zero trust methodologies, right? Going back to my point from earlier, I think you need to really value the ability to profile the devices and understand how UEs behave in your network. You need to be able to use this knowledge in an effective way to make sure that the policies in your network, as you mentioned earlier too, are context-based, right? They take this information into account when designing policy. And you need to find methodologies to be able to detect anomalies in your networks as they happen in real time, right? So if an attack was to occur and someone is already doing malicious things using your devices, you want to be able to know about it as it's happening. So these are the key things I would say.
Thank you.
Sure.
To you, Hagim.
Yeah, I would add more from the organization standpoint. You also need, you touched on this too just before. You need also to build clear set of security guidelines, right? That would come from the security governance teams usually, and translate this into enterprise requirements and more technical type of requirements, IT, cybersecurity requirements, to tackle the threats, right? But from the governance standpoint, is the upper layer. This is what is risky. Then for any technology, you would analyze, how much it's close to the guidelines, and what weaknesses do we have there, and how do we remediate to these weaknesses, or how do we mitigate if not possible at first time. So yeah, I think the guidelines are very important, and that will cascade down to the technical requirements and the implementation by itself. Liron discussed, and we discussed it many times, zero trust. To me, if access control, of course, segregation, visibility, threat protections, and mitigation. So all of this. And I would add also run a pen test, penetration tests on the infrastructure. And that needs to be done not once, but probably several times or periodically. We have the chance to have these teams in our organization that would run this for us every year. It's continuous. And new threats are identified, new remediations are applied. And to finish, I wouldn't say that this is only specific to the manufacturing sector. That would be applied to any other sector. Could be aviation, for example. We will talk about aviation in the future GSMA forum. What kind of threats? Aviation is even at more risk. There is a certification process, compliance for including cybersecurity, but coming from the FAA or ESA certification bodies, and also needs to have an end-to-end security for the airplanes or the helicopters flying. It applies for smart cities, to agriculture, to anything really. So yeah. So I think back to you, Ronan, but it has to be end to end.
Yeah, I completely agree. And what I would like to, my three and a half key point is, you are trying to achieve with private cellular something. Look at that something. When you think about cybersecurity, look at the entire something, but so the devices, the network, the exposure, the compute, the applications, the partners, the vendors, the supplier. Okay, what are the cybersecurity considerations they have to take? Where are the weak points? What do you need to put in place? But look at these different components, but also look at it from an holistic. So I don't want to have one solution here which doesn't talk to a different solution here, which doesn't care about third solution here, because that's going to be adding complexity to an already a very complex ecosystem and environment, right? So have an holistic. That's one point. The other point is SOC, security operations, right? You can put everything, but you need to understand, and you all mentioned it, what's happening, what's going on, who does what, make sure that I employ the right policy. And if something goes wrong, be aware of that, not when suddenly the production line goes off, shuts down, or something happens, but way before that. Be able to understand something is happening. I need to deal with it as soon as possible. So here we have different AI tools and SIEM and reporting and these type of environments. And then the third one is, I think you mentioned is compliancy, right? How does I provide end-to-end compliancy that I must provide, right, in my specific industry, because now I have 5G powered use cases, environments, end-to-end ecosystems. For me, that would be the three main takeaways. So with this, hopefully everybody listening and watching, you enjoyed it. I think I learned a lot. I think it was very fruitful. I want to thank again Hakeem, and I want to thank again Liron. And have a great day. And until next time, bye-bye.